All right, so in this example, we are told that 24% of M&M plain candies are blue. We have a random sample of 100 candies, and we find out that 19 of them are blue, and we want to know what is the probability of getting a sample with 19 or fewer blue candies. So the first thing we have to recognize here is that this is a binomial distribution, right? Because we have successes and failures, blue or not blue, integer only values, so it's discrete, random, variable, binomial. But we are going to do binomial, but we are going to do the normal approximation to the binomial because we're working on chapter 7. So we know the probability of success is 0.24, right? Probability of blue. We know that the probability of failure, 1 minus 0.24, so that'll be 0.76. So that is our probability of not blue. And we know our sample size is 100, right? So we should check conditions, right? Is it a random sample? Yes, it says so, right? Do we have a big enough sample? Is NP greater than 5? And we can say, okay, well, 100 times 0.24, yes, that's greater than 5. So we have enough successes. Do we have enough failures? Same story. NQ, right? 100 times 0.76, that's going to be 76. So that's also greater than 5. And 100 is less than 10% of the population. So we're good there, right? We're good to go. So what is so for our sampling distribution, our normal approximation, or even for our binomial, our mean is NP. So we already know that's 100 times 0.24, so that's equal to 24. Our standard deviation, square root of NPQ. So 100 times 0.24 times 0.76, all under a square root. We'll just throw that into GeoGebra or your calculator, whatever. So square root of 100 times 0.24 times 0.76. So we've got a standard deviation of about 4.271. But I do recommend not rounding these, okay? So the expected number, the mean, 24, we've got 19. We want to know the probability of 19 or fewer, right? So we're going to calculate our z-score. So that was our sketch. 2 is our z-score, x minus np over square root of npq, because we're doing the normal approximation. And the question next is, what x value should we use, right? And so here we're going to draw our binomial rectangle at 19. And we say, well, is 19 included? Well, we're asked for 19 or fewer, so 19 is included. So yes, we are going to go to the upper bound of that and use 19 and a half. We already know NP rather is 24, and square root of 100 times 0.24 times 0.76. All right, so we're going to put that into GeoGebra, calculate our z-score. Right, so we've got 19.5 minus 24 over square root of 100 times 0.24 times 0.76. So we have a z-score of negative 1.054 rounded. And that jives with our picture. It should definitely be a negative z-score. And I'm kind of run out of room here, so we're going to do our third part up at the top. So we're doing the probability of 19 or fewer. We've got our z-score, and we're going to go back to GeoGebra. Go to our probability calculator, keep it on this, right? We want left-sided, and our z-score was negative 1.05. Now I can't remember. 0.54. Okay. So our probability of getting 19 or fewer, 0.1459. So, is this an unusually low number of M&Ms? So here, unusually low or unusually high, unusually low or high, would be if the probability of whatever that is 5% or less. Okay, we are not below 5%, so we're not unusually low. So not unusually low number of blue candies. All right. So when it asks, is such and such an outcome unusual? Is it unusually low, unusually high? You're looking at the probability of that outcome or more extreme, right? Or lower, that outcome, or higher. If that probability is less than 5%, it's unusual. And that's it.